Hi. We are here to demonstrate the new technology, couplers extend. And here we actually got the actual working fixture and program that we actually have from working with one of our partners, Intel. This actually is a customer reference board from Intel where they actually provide to the customer to help them with designing next generation chipset. On the chip here is actually the CPU chip, the new chip, see the little guy there, and then the new chipset, which is the single chip that does everything. And then the memory connector, which is a DDR2 memory connector. Basically, these two chips and this connector will form the new PC, 3 by 5 inch form factor. This is aimed at the ultra-mobile PC marketplace. And as we shrink the geometry, one of the challenges will be that you won't have space for test points anymore. And then the second issue is that when you have high-speed bus on the DDR2, it's also very hard for the designer to be convinced to put test points in them. And with the multi-layer board, some of the signal is going to go inner layer, so even with the bit probe, you will not have test point access to those things. So the challenge comes with Intel and say, well, this is the next generation products, how can you test it without test point access? Well, with the Intel boundary scan implementation on the CPU and the chipset, you can test the connection between the two using just normal boundary scan interconnect test. However, for the connector, there's nothing you can do unless you plug something in using boundary scan to do that. And for this kind of connector, it's real pain to do it in production because you have to plug the card in at an angle and then flip it down to it to lock. To pop it up, you have to move the tool ejector to get out of it. So there's no way you can easily do an automatic insertion of this thing in production, and manual inserting and unplugging is going to be very problematic. So we came up with this new technology, copper extend, which will enable us to provide stimulus through the boundary scan IC to the connector without having to have access to it by talking to the boundary scan chip through the JTAG interface and sending a signal to the connector and then picking it up with the VTEP sensor plate. And that's how our measurement will work. So I'm going to actually show the actual test program running with a passing board here first, a good board. So this is just our regular production test program for ICT and 3070. The new thing here is the testing cover extend capability on it. So here this good board passes, which is obviously important. For any new technology, you better pass good board, otherwise it's going to kick out production real fast. So next I'm going to actually show and try a bed board. One that we actually have injected some board onto the board, and it's going to be a little bit difficult to see with naked eye. And with the magnifying glass here, we can actually see that on this thing here, we get an open pin around here, and a lifted pin there. And on the other side, we have another one here, which is a lifted signal there. And so we've injected two pins open, one on each side of the connector, because it's a two-layer connector, one on upper row and lower row there. And we're going to run the test just like in production. When we get a board, let's see if it's a good board or a bad board. So basically, as we go through the test here, again, we're now testing the cover extend, and good, we capture the failure. So now we get a failing board here, and the failure message tells us you get an open on the pin 62, you get another open on pin 91. So the two pins that we port injected onto this thing here. And in here we have the new cover extend in the graphical debug tools. And this thing here was just set down the vacuum and then run the test. And here for the bad board, we get the failure message just like before, and then running the test plan. And then I can go into the actual test itself, debug the test, which is in this case my connector J6B1, and here we'll bring up the test itself, and then I can actually do things like display graphics, and that will show the actual test results with the measurement on it basically. So here, if I open up this thing here, the red line is actually the low limit, and the blue line is the high limit, and the green is the actual test results on each of the pin, and then the x-axis is the pin number. And so you can actually see the two failing pin here, giving a very low reading on the measurement. And you can also see that one of the nice things about this technology is that we get a big gap between the passing and the failing pin. Just like our good VTEP test jet technology, you don't just move a little bit, it moves a lot basically. So it makes it easy to set limits and also give you a very good noise margin, very stable passing good board, and very easy catching bad board basically. Okay. So next I'm going to show the auto debug tools with this technology here. And so here we can have an auto learn or an auto debug. The difference is in the auto learn, you actually run the test 10 times, and you actually then do statistic on the results, and based on some rules that you set up for it, to then set the limits for, according to the result of the measurement. The auto debug, on the other hand, does it a little differently. In addition to the auto learn, what it does also is do a CPK calculation and comparison. Anything that's unstable will be coming out. So here again, you see on the auto learn, we have 103 pin being tested, and none of the pins being coming out, because in the auto learn mode we don't comment out any pin. And if I now display the graphics again, notice the change in the red and the blue line around the two failing pins. They start dipping down and following the contour of the failing pins here. So if we zoom in and take a look at the area there, you actually see that the blue comes very close to the green, up by a few percent, by about a few percentage point, and the red is down by a few percentage point basically. So this actually is where your test actually would be set automatically for you. Okay. Now if we run this test here, we can actually get some intermittent failure, because the limits are being set on the open pin, which is actually going to jump around quite a bit. So when that happens, what we can do is actually do an auto debug. So for example, assuming this actually is a real board, and we check it out, it's actually a good board. What's causing the failure is actually there's an ECO. Someone cut the trace and said this is now new product. So now if I'm in production, I want to debug the test. Instead of having to manually find out which pin and do this thing here and set the limit in the file and all this kind of stuff, I can just say auto debug, which will help me actually again repeat the measurement 10 times, and then based on the limit results, it will then calculate all the CPK of the measurement. Any measurement that is unstable, below a CPK value of a certain value that you selected in your setting, will now be coming out. So in this case here, the result is out of the 103 pin, 2 pin was coming out. And that's the 2 pin that is having it open on it, because when it's open, the measurement jumps around quite a bit, because it's just basically measuring noise. And when we display the graphics now, you see that the 2 open pins is no longer there. You don't see the failure anymore basically. So now we are back, ready to go back to production. Or if you want it in the debug mode, do recycle to fail, the test will just keep passing. And we could be here all night and it will still be passing. So instead of doing that, let's go back to now finally to the production mode. So now I run my program and just run this board again. Basically now now when you come to cover extend, test passes, and we're ready to go production again. And here there's a few more features here. So for customers say, okay, what if I don't like auto debug? Because it doesn't set the right limit for me. So there's 2 solutions to that. One will be, let's go manual debug. What this thing will do is just bring up the source code. It's actually very much looking like a normal VTEP file, and you see the actual pin being there, test pin for upper limit, lower limit, and the value there. So you can just go into this file and change the limit. It will actually then show the thing. So for example, the customer say, I don't want the upper limit being so low, and so you can say, okay, I got pin 4 here. So if I now change it to, let's say, 3000, okay, the reason why 3000 is the graphics display will scale to go maximum 3000. So don't set beyond that, otherwise it's going to overthrow your display there. Okay. So if you save this file, don't need to exit it, just keep it for handy, and then you can then now do display graphics again. So what you see now on pin number 4, the high limit just jumped to 3000. So you show them how quick it is to do it, and some customers will surprise you with, oh, you don't have to compile, because remember test jet, you modify something, you have to compile. With this cover extend, you don't have to compile the limit file. It just get read in real life and it just run basically. So, okay. And the second thing you can also show would be like, if I want to use auto debug but don't like the way we are setting the limit, you can go into this debug option, which will bring up a file similar to the custom parameter setting option in the VTEP test debug thing. So here we have the ability to change some of these parameters that controls how the auto debug and auto learn would do. So here you can set the minimum CPK, so below this thing pins get commented out, and also you can set high percentage on how the high limit was set, and how the minimum offset of the high limit, and also like the low limit and things like that. So this will give you a way to actually control some of the settings and enable you to do the debug thing basically. So and then of course the usual thing, you can restore your original test, or you can back it up and you can restore the IPG generated test. So actually I put in another option here. This is the original IPG generated test, which basically when you generate the test, the limits are all set to 0. And so basically the lines all down here, so you can actually go in and then learn your limit. So if you start with the IPG generated test, you can also do the demo from here and basically start doing the learning, and you can actually see that the test will actually follow the contour of the test itself. When you do the auto learn, again, it doesn't come out any pins, and 103 pins actually being tested and learned. And now if you do the display of the graphics again, you can actually see that the limits are now being created according to your measurement results.